Hello everyone, we are group 17 and we are working on our final project on the Amazon book review dataset. We are a team of three. I'm Bhargav.
I'm Sai Pranav.
And I am Rajrshi Shrestha.
So to start off with, I'll give you a brief about the Amazon dataset. So the dataset basically contains all these columns: the reviewer ID, which uniquely identifies the reviewer; the ASIN, which uniquely identifies the book or the product; the reviewer name. Helpful is basically a tuple which gives you helpful versus not helpful rating of the review. The review text is the actual review that the user gave. Overall is the rating of the product. The summary is the title of the review, and unique review time and review time are the review times of the other times of the reviews. So to start off with, there was a lot of cleaning that had to be done. The data didn't have information about the book, like the title, the author, and other related stuff. So we had to clean the data and export the data from external sources. So we basically used just the reviewer ID, ASIN, and the rating to start off with. And the ASIN is in most cases the ISBN as well. There are cases where it's not, so we had to make sure if it's a valid ISBN. After making sure if it's a valid ISBN, we used ISBN lib here, which fetches information from Google Books, WorldCat, and Open Book Library. So we use that to fetch the metadata of every book based on the ISBN, and we had it stored in a new column. And after this was done, we had to separate out the title and the author from that particular metadata string, the JSON. So we used pandas and Python to do all the cleaning for us, and we got it separated as such. And then we had to finally merge it back to the original data so that we had this whole frame where we had the ASIN, the title, the author, the reviewer ID, helpful tuple, the overall rating, and the review time. So this was all the data that we needed for our data visualization. Next, we wanted to build an intelligent system of sorts so that the visualization has some sort of recommendation. So we set out to build a book recommendation system, and we used Python and collaborative filtering to achieve the recommendation part. And the whole project was done using Flask and JavaScript, and the visualizations were done in D3. So the main logic of the project was done in Python and exposed to the web page as through as an API through Flask. So we have the first API here, which is get books. So what this basically does is, in order to make recommendations to the user, we wanted some sort of user input to know his preferences. So we had to make him rate a few books. So which is what we're doing with this interface here. So in order to get a list of books for the user to rate, we had to find out the most popular books. We did that by using the average rating and the number of reviews the books had. So let's look at how that interface looks. So we have a list of books here. One can go ahead and rate a few of these books depending, and if you have not read a book, you can always choose to skip. I'll just rate a few of these books so that we get a decent enough recommendation. So after having rated all these books, one can go ahead and click the show my recommendations button, and then this is going to show your recommendations. And as you can see, we rated Harry Potter kind of high with the 5-star ratings, and so it's recommending us the other books from the Harry Potter series. If we want to change the recommendations, we can go ahead and rate a few other books, and then we can try show my recommendations, and this is going to refresh the recommendation and give you a new list of recommendations. So after you've got these recommendations, you can go ahead and view information about these books. So when you're double clicking on these books, it's going to make an API call, and we have two visualizations here which are about this particular book, The Girl Who Kicked the Hornet's Nest. So the first one is trying to show the seasonality of how people read books, and as you can see, we wanted to know if there are any particular months where people read books. As the calendar heat map suggests, we can see the book is read more towards the end of the year rather than more on the start of the year. And the next visualization is a simple bar chart which shows how users have rated the visualizations. So as you can see, around 847 people have rated the book 5 and 293 people have rated the book 4. So this is kind of how our web app looks. Going back to the main logic of the recommendation system, we're using collaborative filtering for making the recommendations. And there are two sorts of collaborative filtering techniques. One is user-user collaborative filtering, and the other is item-to-item collaborative filtering. We are using the former, the user-user collaborative filtering. So after getting the list of ratings from the user, what we do is we go back to the Python code. Here we try to get the most similar users based on the Amazon Book Review dataset. So this method here is basically going to try and find users who have rated books similar to you. And after we find users who are very similar to you, we try to fetch books that they have read but you haven't. So this is more sort of like how things work in real life. People have mutual interests, and that's how user-user collaborative filtering works as well. And after we have got this recommendation, we send it back to the app in the form of API, and that's how we populate the bubble charts. And we have other methods here which we use to get the data for the heat map as well as for the ratings. So everything as such is exposed in the form of an API and goes to the web app, and that basically sums up our project. Thank you.
Thank you.